Hello, class. These are our four notes, fundamental theorem of calculus that we're looking at right now. As long as I am on track for making videos this chapter, I might as well keep up with it. So let's see what we have. So we're starting out with the fundamental theorem of calculus. So this is going to put together everything we've learned so far this chapter. So we're looking at taking a definite integral that goes from a to b. So this is my lower bound and my upper bound of f of x dx. And what we're saying is if we go ahead and integrate this and find that original function or the antiderivative, so remember this one's a derivative, we want to work backwards and find the original function. This is going to be the equivalent of taking that original function and evaluating it at b minus taking that original function and evaluating it at a. So this is the fundamental theorem of calculus. Often we will look at this kind of in a different way, where we have solved it for f of b for the second value. And so we're going to write that f of b is going to be equal to f of a plus, and we'll do this a lot this year. I just want to mention it right now. I don't want to ignore it and bring it back later. So what I did is rearrange this and added big F of a, my original function, evaluated at a over on this side, so that I have big function f of a. I keep saying big F, but it's my original function. It's not my derivative. So f of a plus that integral from a to b of f of x dx. This is my derivative. This one's my original function, or the antiderivative of this one. So this is a start, and then we think of this as accumulation. So start plus accumulation. Again, too early to worry a lot about this. You can't even read the word accumulation, but I want to make sure that I'm talking about it from the beginning this year. Okay, so looking at our definite integrals. So we're going to evaluate. So we're kind of putting everything together. We are having to remember how to integrate, and then we're also going to do this step where we're evaluating as well. So when I integrate, and on definite integrals, I'm not going to have the plus c because I know exactly what's going on. This is going from 1 to 2. So the first thing I do is just integrate. So if I have x being squared, I have to increase that exponent. Now it's a 3, and I divide by 3. Minus this 3 did not have an x at all. When we work backwards, now it's going to have an x the first power. And because this is the thing I'm evaluating, I'm going to put it in brackets, or sometimes I just do like a line over here, different notations on different stuff. And I am integrating this over this interval from 1 to 2. My lower bound is 1, my upper bound is 2. And then I'm going to first plug in 2, because that's this part, right? I have to do, so this is my big F now, and I need to do f of b minus f of a. So this is my big F, and I want to evaluate it at my upper bound minus, and then I want to evaluate it at my lower bound. So I'm going to have 2 cubed over 3 minus 3 times 2 minus, and then I'm going to like bracket this off because I'm subtracting. I know that sometimes I forget to distribute that minus sign, and there's a big minus sign right here. I can't forget about that. And then we're going to substitute 1. So I'll have 1 cubed divided by 3 minus 3 times 1. All right, so let's see what we got. So let's see, it makes 8 thirds minus 6 minus 1/3. And then when I distribute this minus sign, now I have a plus 3. So I'm going to put my fractions together and put my integers together. So 8 thirds minus 1/3 would be 7 thirds. Minus 6 plus 3 is a minus 3. And then I do want to go ahead and rewrite this fraction as 7 thirds minus 9 thirds. And this means we have a negative 2 thirds. All right. So let's take a look at the next one. So right now we're not worried about what this means or a picture of it. We're just working on the mechanics right now. So it's really kind of important for us to note. Okay, on the next one, I'm looking at the integral from 1 to 4 of 3 times the square root of x dx. So remember, 3 is just a constant. I could put that out in the front if I wanted to and just multiply everything by 3 at the end. And I'm going to write my x as the 1/2 power. So when I integrate, I need to add 1 to this exponent. So it's going to be 3/2 power. And then after I'm dividing by 3/2, I'm going to be multiplying by 2 thirds. And then we have this 3 out front. And then we're evaluating this from 1 to 4. So I've got my lower and upper bound. So my plan was to evaluate all this and then multiply by 3 at the end, but I kind of just want to do that. That would make my life easier. So 2x, and remember, if I have 3/2 power, I really have an x and then a square root of x. And this is, again, from 1 to 4. I don't know if that's going to make it easier or not. It might. So first we substitute 4 in. So 2 times 4 times square root of 4, and then minus, and then we're going to go ahead and substitute in 1. So 2 times 1 times square root of 1. I probably should have just left it at 3/2 power. So this is going to be 2 times 4 times 2. So that's going to be a 16. 2 times 1 is just a 2. And so my answer is 14. So my definite integral is 14. So these are definite integrals because I have a lower and an upper bound. Before, in the first section in 4.1, when we were just learning kind of basic integration, when we learned how to integrate these things, we did not have numbers there. Those were indefinite integrals. So definite integrals means I definitely know what my lower and my upper bound are. All right, the next one, I have a tangent squared. So that's where I have to go back and kind of just remember. So jogging my memory, if y equals tangent x, then y prime equals secant squared x. So this one might look scary, but remember, we're just going backwards from our derivative to our original function. So when we integrate this, it's just going to be tangent x. So I'm going to integrate it and say, okay, now I have tangent x. Many times I don't do anything on this side. You'll just see like a bracket on this side. So I'm going to do this one a little bit differently just so you can get the idea. So this one, my lower bound 0, my upper bound's pi over 4. And sometimes it's just a line and not a bracket. So we need to evaluate the tangent of pi over 4 minus, and then we're going to have to do the tangent of 0. So that means I need to draw some pictures of trig functions, or triangles at least. So here's my pi over 4. So pi over 4 is 1 square root of 2, or root 2, 2. Like, it doesn't really matter which way you want to do it. But when I'm looking at my y over my x, that's what tangent is. This is just going to be 1. And then tangent of 0 means I need to look at this point right here. And that would be 1, 0. And again, I want my y over my x. So that'll be minus 0. So my definite integral is 1. And again, you don't really know what we're finding right now, and that's fine. You might be putting it together. You might be thinking about the pictures in 4.3. But if you're just doing the mechanics part of it also, that's okay. All right, this one has an absolute value. So absolute value means we won't have anything negative. So let's see if we can figure out what the heck is going on. So absolute value of 2x minus 1. So let's just graph y equals absolute value of 2x minus 1, right? I could make that graph. So the way that graph would look is if I think about what I would have to put in for x to make this a 0. If I had 2x minus 1 equals 0, my x would be a 1/2. So if this is 1, here's 1/2 right here. That's going to be my vertex. So my vertex is going to be 1/2 comma 1. And then I need to be thinking about what kind of a pattern would I have. And so I know that absolute values go something like this. And I might also want to know where it crosses over here, right? So I might be curious about that. I'm going to write plus 0. So if I'm thinking about where do I cross the y-axis? Let me go ahead and draw this up, and then I could figure that out. And this is going from 1 to 2. Okay. Wait a minute. Where is it going from? Oh, my lower bound is 0. My upper bound is 2. So this is what I'm trying to find. I've got 2 little triangles here. All right, and I said it would be kind of nice for us to know this point. When my x is 0, what is my y? So y equals absolute value of 2 times 0 minus 1. Well, 2 times 0 is 2 minus 1. Or sorry, 2 times 0 is 0 minus 1 is a negative 1, but I'm taking an absolute value. So this would be a 1. So this is going to be 1 on my y-axis. So if I'm kind of thinking about triangles, right, this is totally easy. So what we're trying to put together now is we just did the mechanics. We didn't draw any pictures. And now what we're kind of hoping to put together is when I'm finding this definite integral And we can do it with calculus. We don't have to do it with the picture, but I'm really finding the area of this part and I'm finding the area of this part. But how do I do that when it's an absolute value? Okay, so what I have to think about is I have to think about how this is two different lines. And I'm going to grab a marker kind of here to help me out. So the issue with absolute values has always been that they are pointy and they are not differentiable. So we're going to have to look at two different parts. I'm going to have to look at a pink line here. And my pink line is just going to be the line y equals 2x minus 1. If you think about how this line is going, it's starting down here at -1 and it's going up. And so this line is going to be y equals 2x minus 1. And when I look at this line and I look at this area right here, so now I'm going to make it that kind of pink area, it's only from 1/2 to 2, right? That's the only part for that one. So if I was going to write an integral for this part, I would make it go from 1/2 to 2. It's my lower and my upper bound of 2x minus 1, and then I put a dx over here. So I think that part kind of makes sense. But then how do we get to that other part of our line? So here is my other line. I've got this green line right here. So this one is really, it's like the same line, but it's going down instead. So it's starting here at a +1, and my slope is down instead. So if I'm finding the equation of this line, it's really going to be the negative of the other one, which is going to be, I guess I got to move my paper up here, which is going to be a -2x and a +1. And when I do this integral, it's going to go, so I'm looking at only this little green area, from 0 to 1/2 of -2x plus 1 dx. So let's go ahead and write this down. So my integral is going to be these two parts together because I don't know how to integrate an absolute value. Like that's the issue here. I can't do anything with that, but I can totally integrate these guys. So I want to rewrite this as my integral from, grab my pencil again, 0 to 1/2 of -2x plus 1 dx plus my integral from 1/2 to 2 of 2x minus 1 dx. So I'm adding those two little areas together. Fortunately, everything is above the x-axis, so it's all going to be positive numbers in the end. So I'm not going to have like a whole bunch more weird negatives or anything to worry about. So when I integrate -2x, I know I need to increase that exponent from 1 to 2, but then I'm dividing by 2 plus, and then this is going to be a 1x, and I'm going to integrate this one from 0 to 1/2, and then plus. Second one, if I have a 2x, we're going to make that 2x squared over 2 minus. This had no x at all, so x is 0. When I increase that, I get x the first. So I don't need to put anything else there. Oh, this is a 1/2 to 2. So my lower bound is 1/2, my upper bound is 2. Okay, I do want to kind of clean these up because they're bugging me. So -x squared plus x. And then this is going to be x squared minus x. All right, now we have to do a whole bunch of substitution, right? And then this is where we should probably also take a quick break and look at how to double check this on our calculator. So if I plug in 1/2, I'm going to have a 1/2 squared plus a 1/2 minus, and then I'd put in 0. Well, that's going to be easy, right? -0 squared plus 0. That's just going to be gone. All right, plus, then I'm going to evaluate this one by plugging in 2. So 2 squared minus 2, and then minus. I've got to now substitute 1/2. So this is where all of my green writing now is unfortunately in the way. So I'm going to have a 1/2 squared minus a 1/2. All right, I was able to squeeze it. So now I've got to go through and just kind of see what's going on. So this one, when I square, is now going to be a -1/4. And then I have a plus 1/2. I'm not going to actually try adding or subtracting anything. I just want to go through and do all my squares and kind of distribute, lay everything out. This is going to be a +4 and a -2. Let's see, this is going to bring a minus to this 1/2 squared. So that'll be a -1/4. But then my minus also gets distributed to this 1/2 right here. So it's going to be a plus 1/2. All right, so let's see what we got going on. I would definitely combine these two. That's going to make a 2. Let's see, I have a 1/2 and a 1/2, makes a whole. And let's see, I've got a 1/4 and a 1/4, so that's going to be minus 1/2. So 3 minus 1/2 is going to be 2 1/2 or 5/2. That was a lot of work. Let's double check our answer using our calculator. So we can do not an indefinite integral, but a definite integral on our calculator. So I want to go down to, let's see, math. And we've done a lot with numerical derivative, and right below that, where it says FNINT, that's what I want. So it looks just like the integral should. So my lower bound was a 0. My upper bound was a 2. And then inside here, I needed absolute values. So I kind of think those are under math, but it's been a while. There's my absolute value right there, number 1. So under math, and then under number, I found that. So I'm going to press enter again. Now I've got my absolute value signs, and I had a 2x minus 1. Okay. And then this needs to be dx, and then I'm going to press enter. 2.5. So really cool that we could check our answers like that. Really cool that the math worked out. So this one was tricky again because I was trying to find, integrate something that was an absolute value, right? So I had to look at this graph. I had to come up with both the lines, and that also gives you a sense of why these are not friendly functions, right? This side was different than this side. So that's why we've got a pointy bad thing kind of going on. It would have been super easy, I guess, if we just found the area based on the triangles. So that would have been a different way to think of it too. But I wanted us to see the math that we would have to go through and work out and how absolute values work. Okay, so looking at our next page, we're going to look at something that's a little bit more different, a little bit more difficult, I guess I should say. So now we got a word problem where they don't just give us a definite integral to work out. So we want to find the area of the region. Okay, so area means we're going to be integrating it, of the region bounded by the graph y equals 2x squared minus 3x plus 2, the x-axis and the vertical lines x equals 0 and x equals 2. Okay, so I know that this is a parabola. I know it's a right side up parabola, but it might be kind of nice. Like I can graph all the rest of it. I want it to be bounded by my x-axis, the vertical line x equals 0, so that would be my y-axis, and x equals 2, right? So I'm going to have some kind of a curve up here or maybe down here, right? And I'm going to be looking between that graph and this line over here and my x-axis. So it's going to like box something in. But I need to figure out where this is at. So I probably want to maybe figure out the vertex, right? So in order to figure out the vertex of a parabola, I could complete the square, or I could use that really easy trick. The vertex is going to have an x-coordinate of negative b over 2a. So if b is a negative 3, then this is going to be a positive 3 over 2 times a is 2, so positive 3/4. And then I might want to know the y value there, right? Because I'm trying to figure out, is it up here or is it down here? And I'm not really sure. So let's just do y of 3/4. All I really care about is it positive or negative, right? Because I know the shape of a graph. I know that 3/4 is going to be my lowest point somewhere between these two. I know 3/4 would be like right about here where x is 3/4, but I want to know the corresponding y value. I want to know if my curve is below this x-axis or above this x-axis. I kind of think it's going to be above, but let's just see. So if I do y of 3/4, and I have 2 times 3/4 squared, let's see, 3/4 squared would be a 9/16, and then minus a 3 times 3/4, so minus 9/4, and then plus a 2. So I really feel like there's no way that's going to be negative. I don't have to worry about that. 18/16, like this is going to be 9/8, that's 1 1/8, plus 2, so 3 1/8, minus 2 1/4, something like that. So I know it's going to be positive. So I'm good to go. So I know that when my x is 3/4, I'm at some kind of positive y value. I don't care what it is. My graph's going like this. So this is the area of that region I'm looking for. And this one does say area. So even if it was below my x-axis, I would be giving a positive answer anyway. So the way I would set this up is I'm looking from x equals 0 to x equals 2. Those are going to be my lower and upper bounds. The curve I'm looking at is 2x cubed minus 3x plus 2. And the way this works is it's always between our curve and our x-axis unless we do something different. So this is all that we need to do right now. So I'm first going to integrate. Cubed is going to become 4th power, divide by 4. X is going to be squared, divide by 2, and then 2x. And this is from, oh, you know what? I copied that wrong. That's a 2. I really thought it was a 3. It's a good thing I looked over and double checked it. So squared. So then if this is squared, I have to make this cubed, and this is a 3. Okay. Thank goodness we caught that early on. All right. So now I need to substitute 2 in. So 2 times 2 cubed over 3 minus 3 times 2 squared over 2 plus 2 times 2, and then minus, and then I'm going to plug in 0 for everything. But 0 cubed, this one 0, this one 0, it's just going to be a 0 here. So it won't always work out to be a 0. I could have, I suppose, like, I don't know. There could be some times when it's not a 0. It's not every single time, but just be careful about those. So this is going to be, let's see, 8 times 2, 16 thirds, minus, let's see, 4 times 3 is 12, divided by 2 is 6, plus 4. So we have 16 thirds minus 2, or 16 thirds minus 6 thirds. And our answer is going to be 10 thirds. I totally ran out of space. I had to go all the way over here. And sometimes you just look over here and you think, like, does this sound like a reasonable number? This would be 3 1/3. Or you go to your calculator, right? Now that you know how to do this on your calculator, we could double check our answer there. So I'm going to go to math, and I want a finite integral. So definite, finite because I know what it's going to be. It doesn't go on forever. It's not infinite. It's not indefinite. So I'm going to press 9. And then I put in all my information, 0, 2. This is going to be a 2x squared minus 3x plus 2. And then I have a dx. And I get 3 1/3. So my answer is right again. So mean value theorem for integrals. So if f is continuous on the closed interval, then there exists a number c in the closed interval ab such that the integral from a to b of f of x dx equals f of that c value times b minus a. So this right here is the area under the integral area of, I guess I'm just going to call it area of integral, which is kind of sloppy, but I'm trying to get us to see what that means. And this is a rectangle. And f of c is my height. This would be like the height right here. And then my base would be the b minus a. So let's just draw a picture of what this looks like. And maybe I want to just write rectangle here. And I don't want to have those arrows. Okay, so what we're saying is if we have some kind of curve, and let's just go with one that looks like the last one, and here's my a and here's my b. When I'm finding my definite integral, I'm finding this area right here. So what they're saying is there's going to be a rectangle somewhere where I'm going to get the same area by choosing some magical height. And that height's going to be f of c. So let's say that this, and I don't think that looks quite right, but let's say that this would be that same area. So I'd have an area of the rectangle is going to be area of the integral. And there's some value c where this height is f of c. So that's what's going on. And maybe we should write this as an ordered pair. C comma f of c is going to be that point. So we've got an area of a rectangle equals the area of an integral. So to just go back a step, mean value theorem that we did before, we did slope of the line. So your average slope was the same thing as your exact slope, which was your derivative. So a different way to rewrite this is if I wanted to do an average. So think about how this is going from A to B. So if I want to do an average, I would say 1 divided by b minus a of that integral from a to b of f of x dx. So I'm averaging it out by dividing by the width, right? That's what I'm really doing. If my width goes from a to b, that's that number b minus a. So I'm trying to average it out by dividing by that. I'm dividing by how wide it is. B minus a is how wide it is to find the average. So we're going to find an average value of this function on this interval. So the interval is going to be my lower and upper bound. And I'm going to have 3x squared minus 2x dx. Average value means I have to do that 1 over b minus a. So 1 over 4 minus 1. So that's going to be a 1/3 in front of this integral from 1 to 4. And probably just could have integrated it right now. So let's go ahead and leave the 1/3 there. And let's integrate. 3x squared will become 3x cubed over 3 minus 2x squared over 2 from 1 to 4. And then I want to simplify this. So 1/3 of x cubed minus x squared. All right. And then we're going to plug in some numbers. So the 1/3 stays out front. We'll have 4 cubed minus 4 squared minus, and then I'm going to substitute 1 in. 1 cubed minus 1 squared. And lots of algebra here. So you can see where if this is AP test, you're totally stopping right here, right? You're not going to keep going. But we do need to practice some of this stuff. We do want to keep our algebra skills sharp. So 4 to the third is 64 minus 16. This is going to be a minus 1 and a plus 1. All right, so 64 minus 16 is a 48. So 1/3 of 48, which is 16. So our average value is 16. So again, it's average because this is my area of the whole thing. And then my width is 3. So it's 3 wide. That's the base of my rectangle or the base of my shape. And so if I want to find an average, I'm dividing by how wide it is. So I'm taking this value, 48, and I'm dividing it by 3 because that's how wide it is. So that's how we get that average value formula. This last one is kind of weird. It's okay for you not to really understand it right now. For now, like we're just memorizing. So the second fundamental theorem of calculus, if f is continuous on an open interval I containing a, then for every x in the interval, if I have the derivative of the integral. So you must be thinking like, hey, don't those two cancel each other out? But then this one has a t in it, and this one's from 0 to x. Like this is just getting all kinds of crazy. It's going to be the same thing as just f of x. Because I think about how when I am integrating this, right, I'm doing capital F of x minus f of 0. But then I want to go back and take a derivative again. So it's basically like the derivative and the definite integral are basically like canceling each other out. So what my steps really are is I'm going to look at taking this guy right here that has a t in it, and I'm going to be substituting an x instead. So, all right, so let's see. So this is going to be x squared plus 1. But then the other thing I have to do, so first I just subbed my x in there, but I also have to look at what's my derivative of this guy right here, because that could be like a chain rule issue. So derivative of x is just a 1. So my answer on this one is going to be square root of x squared plus 1. Okay, on the next one, first I'm going to substitute an x squared in here. So first you're going to substitute. So square root of x to the fourth squared plus 1. But then I also have to take the derivative of x to the fourth. That's going to be a 4x cubed. And I think I want to write this one in front. AP, what is it called? It's Organic Chemistry Tutor, has a really good video on this. But ultimately, like what you come up with is you're going to sub value in for t, and then 2, take derivative of that, of this thing right here. So you're working with this thing. So first you plug this thing in for t, then you take the derivative of this thing. Okay, so we are going to try it right here on this one. It says find the derivative of f of x equals this integral. So that means if I want to find the derivative, then I am taking d dx of that whole thing. So this goes from pi over 2, which is a constant, so we don't have to worry about it, to x cubed of cosine t dt. So again, I'm going to substitute x cubed in for my t. So that gives me cosine of x cubed. And then I'm going to have times. Then I take my derivative of x cubed. That's going to be 3x squared. All right, that's it. So these are really long notes. I hope that we are not doing this completely on our own, but who knows? Please ask questions, send me an email, whatever you need to do. Hopefully we will see each other soon.